So you picked a 12-volt linear actuator off a spec sheet, you know the stall force. But here's the question nobody asks until it's too late. Will it actually move your load fast enough? Because stall force alone doesn't tell you what happens after you bolt on a gearbox and a lead screw. That's where most projects run into trouble. This calculator solves that problem before you cut a single piece of metal. You feed it 3 inputs: your actuator's stall force, the gear ratio, and the lid screw pitch. And it tells you exactly 2 things: how much force you'll get at the output, and how fast the actuator will actually travel under load. It also works in reverse. If you already know the force and speed your application demands, it'll back calculate the gear ratio or lid screw pitch you need to hit those targets. Here's the core idea in plain language. Your gear ratio multiplies torque but divides speed. Your lead screw pitch converts that rotational motion into linear travel. A coarse pitch moves faster but pushes with less force, and a fine pitch moves slower but hits harder. And drivetrain friction always takes a cut, so the calculator accounts for real-world efficiency losses instead of giving you textbook numbers that fall apart on the bench. Where does this matter? Let's take a look at some practical engineering applications where these sizing trade-offs are critical. Think about a shop press where you need 600 pounds of force but speed is secondary. You choose a high gear ratio and a fine pitch. Now compare that to a camera slider where you need smooth, fast travel with minimal load. Completely different drivetrain setup. Or consider an automated gate system where you need moderate force and a specific closing speed to meet safety requirements. Each application lands at a different point on the force versus speed trade-off, and this calculator maps that out instantly. Stop guessing whether your actuator can handle the job. Find the link in the description below to use this calculator and read the full engineering guide.